Today I'm joined by Nate from Impossible Objects. How are you?
Doing well, thank you.
Fantastic. It's great to have you here.
It's wonderful to be here.
Yeah, it's a good show so far. I know we're only half a day in, but
Yep.
I think things are busy, it's interesting, and I'd really like to talk to you about your 3D printing, and you're described as revolutionary. So please tell me some more about that.
So what makes us revolutionary is actually our speed. So if you look at most 3D printers, it's basically they're so slow that you can only do prototyping, one-offs, two-offs, something like this. But we're literally 15 times faster than the next fastest 3D printer that's out there. So, and to put that in context, because 15, it sounds like a big number, right? But it's putting that in context. It's the difference between the fastest human being running the mile and a Formula One race car on an open straightaway, right? Like that. It is literally that type of a difference. It's a different race. You're not even in the same competition, and there's actually significant upside on our speed that we'll be getting in the next couple years on top of that. So we'll expect another 4x faster, right? So not 4%, not 40%, but like 300% faster than where we're at today in the coming 2 years. So again, this is the advent of mass scale additive manufacturing.
Wow,
Yeah.
that's significant. It's not just, as you say, it already sounds like a big number, but when you say comparatively, that's huge.
It's huge. It's absolutely huge. It's absolutely huge. And that's compared with the next fastest. I mean, like, there's 3D printers out there that were 1,000 times faster than, right? So or 300 times. And when you think of like 300 times faster, that's like you can do in a day what it takes somebody else to do in a year.
Yeah.
Right. Like it's just a whole different world. And what's really cool is that you can do it. So our material properties, you might think, oh, you're faster, but you know what are you getting on the other side?
Expense,
At what expense, right? And so we make carbon fiber peak composites. Mm-hmm. So this is a true composite, 50, 60 micron layers, depending on, again, the choice of the printer. You can choose what you want to do. And what's really good about carbon fiber and peak is that it has extremely high temperature and chemical resistance. So I think this gets up to like 250 Celsius or 500-ish Fahrenheit. So again, really hot. And it's resistant to virtually any chemical. I mean, like I think hydrofluoric acid can break it down, but like hydrochloric acid won't, right? So it's it's something that, again, in the context of electronics tooling, where you're looking at things that can withstand very high temperatures and caustic environments, it's a perfect material for that. So additionally, we also have really good tolerances. So for something like this, which is, 14-ish, 15-ish inches long, we'd have about plus or minus 1 micron tolerances from corner to corner in the vertical, and about 150 micron tolerances in the XY plane. So that's yeah.
So you still have the precision, you have the durability, and the resistance is there. That's fantastic. It seems that you're ticking all the boxes. And has that change been driven by your customers, or did you see a space and a need for that change?
Honestly, it was our app. So when we were looking at when it was being developed, part of what we were looking for was something that would add real value, right? And so we could see that the carbon fiber would, but it's also something where carbon fiber composites are it's a very manual process. So there's a lot of labor, a lot of cost that's involved with that. And so being able to additively manufacture that was something that we were like, well, we can actually provide a real value proposition, because you're basically totally extracting all that labor cost out. It's like, you still have labor, but it's low-level labor versus highly trained labor. So it really reduces your costs in a significant way.
Yeah, so there may be that initial up fee that you're going to implement, and in the long run, you're actually saving money because of that labor cost. And
Oh, for sure.
hopefully the efficiency of it is to be far greater than if somebody were to do it manually. And
I mean, when you think about it, like in most 3D printers, because of the speed, it totally changes the economics of manufacturing. And part of that is that when so a normal 3D printer, the machine cost, it's so slow that the machine cost per part makes up over 60% of the cost of the part. So like that's not the materials, it's not the labor, it's actually the cost of the machine, right? When you have a machine that goes 15 times faster, what that means that you can produce 15 times as many parts, so the cost of the machine is basically 15 times smaller. And additionally, your labor, if you have only one person there, your labor drops by a factor of 15. And so in the manufacturing of our parts, instead of 60% for, say, the machine amortization, it's actually the machine, overhead, and labor is all less than 10% the cost of the part. So it just totally changes the economics of manufacturing.
that's incredible. Thank you very much. I appreciate you going into the detail about the machine itself, and overall it's going to be saving people money and it's going to be saving time, and there's
For sure.
smaller chance of inaccuracy, so it's all significant in the industry. So thank you so much for your time, Nate. I really
Wonderful.
appreciate it.
Thank you.
Thanks.
All right.